All right, let's look at this factoring. Greatest common factor. Look for the greatest number that can be divided out and variable. You can divide 4 out of both of these. You can divide x squared out of both. We have 2 terms, so we need 2 blanks. 12 divided by 4 is 3. If you divide x squared into x cubed, you get just x. 4 goes into -8, -2 times, and all the x's are going to be knocked out, and that's your factorization. It's nice because you can use the distributive property to check. Second one, we can divide a 5 out of everything. We can divide an x out of everything. 3 terms here, so we're going to have 3 blanks. 5 goes into 10 twice. X goes into x cubed, x squared times. 5 goes into -15, -3 times. X goes into x squared, x times. And 5x goes into itself once. Okay, don't say it cancels. We're dividing here. Nothing goes to 0 when you divide, unless it already has 0 in it. Okay, this one. I would divide the negative out of the front. You usually want a positive first term. So I'm going to take out a -4. I can take out as many as 1a from both. That's my GCF for the a's. I can take out as many as 2 b's. And so, again, we're going to have 2 sets of parentheses here. -16 divided by -4 is 4. We took 1 of the a's. We took 2 of the b's. 20 divided by -4 is -5. We took the a. We took the b's. That's our final. Okay? These do not have greatest common factors. Okay? Kind of is implied in the directions. And so anyway, we're going to factor these using the FOIL factoring pattern. So we're going to have 2 sets of parentheses, 2 binomials. Remember, the last 2 positions need to multiply to be -8 because we have a 1 in front of the x squared. The 2 numbers need to add to be -2. So the numbers that will multiply to be -8 and add to be -2, that would be -4, right, and +2. And it is not an equation. It's not equal to anything. It doesn't have a solution. We're just writing it in a different form. Okay, next one, another binomial. Last 2 terms need to multiply to be 16. They need to add to be -8. They're both going to have to be negative, right, to get a -8x and to get a +16 product. -4 and -4, right? By the way, since it's being multiplied by itself, you could also write that as the quantity x - 4 squared, which notice is not x squared plus 16. It's this whole thing. Okay, this one's interesting. This is really x squared plus 0x minus 100. If you want to think of it as a trinomial. So you'll have your x and your x. We need numbers that multiply to be 100, add to be 0. So opposite signs, same value. If you do a -10 and a +10, you'll get a -10x and a +10x, and that middle x term will cancel. This is what's referred to as the difference of squares pattern, by the way. These are both perfect squares. They're being subtracted. There's no x term. All right, last one here, we've got a 2x squared, and the game changes here. We're going to have a 2x and an x. The last 2 positions need to be multiplied to be -7, which is nice because there aren't many numbers that do that. And we just have to kind of guess and check here and see what we can get to work out. By the way, I notice, so the 7, I'm going to have a 7 and a 1. And one needs to be negative and one needs to be positive. I'm noticing that 7 times 2 is 14, which is really close to -13. So actually, I'm going to put the 7 over here, and I'm going to put the 1 here. Sorry, it's a little messy. And the 7 is going to need to be negative because we want a large negative number. So if we do a -7 there and a +1 there, 2x times x is 2x squared. 2x times -7 is -14x. 1 times x is +1x. Notice that adds up to -13x, and then 1 times -7 is -7, and we get it to work out. So it's the quantity 2x plus 1 times the quantity x minus 7. And again, until you get a lot of practice here, you may have to try a bunch of different things before you get it to work, okay? That's why it's called guess and check. Right, solving quadratics using factoring. We got to decide if we need a GCF or FOIL, or I guess it could be both. Anyway, this one, we've got a GCF of x. So factor that out. We get an x minus 5 inside parentheses. And 0 product property says if things multiply to be 0, then one of them has to be 0. So either x has to be 0 or x minus 5 has to be 0. And if you solve that second equation, that would give you that x is equal to 5. So remember, most quadratics should have 2 solutions. And if they don't have 2 solutions, you should be able to explain why they don't have 2 solutions. Remember, these things need to equal 0, so get the negative 12x on the other side. We've got 4x plus 12x, 4x squared plus 12x is equal to 0. Once again, it's a GCF. Factor out 4x. You'll be left with an x. You'll be left with a 3. Two things multiply to be 0, so either 4x equals 0, and x would have to be 0 to make that work, or x plus 3 has to be equal to 0, and x equals negative 3 would make that work. Okay, no GCF here, so we could do a FOIL setup. And we've got an x in both positions. We need numbers that multiply to be negative 21, add to be 4. Let's see, is that a positive 7 and a negative 3? That'll work, right? So set x minus 3 equal to 0, set x plus 7 equal to 0. Those two things have to multiply to be 0. So that would give me x equals 3, or that would give me x is equal to negative 7. Okay? Last one here, got to get it equal to 0. So x squared minus 9x plus 20 is equal to 0. Once again, no GCF. We'll factor using FOIL. Got an x and an x. They have to multiply to be positive 20, but they have to add to be negative 9. So we're going to need two negative values. How about 4 and 5 will do that, right? So I want x minus 5 to be 0 or x minus 4 to be 0, and that would give me a solution of 5 or 4. All right. Now we got a few more. X squared minus 16 equals 0. Remember, that's x squared plus 0x minus 16 equals 0. So we need numbers that multiply to be negative 16, add to be 0. Guess what? If you pick the same two numbers with opposite signs, negative 4 and positive 4, that'll give you a plus 4x and a minus 4x, and you'll get a 0x in the middle. So you want x minus 4 to be 0. You want x plus 4 to be 0. That gives you solutions of x equals 4 and x equals negative 4. You could write x equals plus or minus 4 if you wanted to. And that makes sense, right? 4 squared is 16, minus 16 is 0. Negative 4 squared is 16, minus 16 is 0. Checks out. All right, leading coefficient here, we're going to have to guess and check. Luckily, 3 doesn't have a lot of factors. We'll have a 3x and an x. All right, so we need numbers that multiply to be negative 4. That could be negative 1 and 4. That could be positive 1 and negative 4. That could be 2 and negative 2. We can put them in different positions depending on what situation we have. This number in the middle needs to be small, so we need things that are pretty close together. I'm going to try, again, we can try different things here, but I think if I pick the negative 1 and the 4, I think if I put the negative 1 in a place where it would get multiplied by the 3, and I think if I put the 4 in a place where it would get multiplied by the x, I think that'll give us something pretty good. And let's see, we need a negative, so the bigger number needs to be negative, I think. Okay, let's try this. 3x times x is 3x squared. 3x times 1 is 3x. Minus 4x minus 4, that works, right? Yeah, that's going to give me a minus x. Okay, so there's the factorization. It equals 0. Now remember, you want the values inside parentheses to equal 0. So you want 3x minus 4 to equal 0 or x plus 1 to equal 0. This one's easy. Negative 1 plus 1 is 0, so x is negative 1 there. This one you actually need to solve. Okay, it's going to be a fraction. You'll get 3x equals 4, and it looks like x is going to be 4/3, and those are your two answers. So very often you're going to get a fractional answer when you have a coefficient out in front of this like that. Okay, and we'll pick up the next video with the quadratic formula.